Hello, welcome to the wonderful world of random sequencing. I also have another YouTube channel called Sequencing Random Numbers, and we're going to be dealing with Super Lotto Plus, and one sequence in particular, this sequence right here. But before we get into talking about the sequences, we'll have to explain a few concepts here. Binary numbers is like the calendar dates. Now, calendar dates and ticket numbers, they're very, very important. They help to spell out the sequences. So um, I will talk about right now. Binary numbers is basically, here's a binary number. Now, notice that in the calendar date, you see how you have the 11 right there? Well, that could be represented by, it's a binary number as number 3. It's equal to number 3 in binary notation. So, but there, this sequence got repeated over here. You can see that. And we're going to binary decimal numbers. Binary decimal numbers are two cells that have binary numbers and decimal numbers. In other words, you have the 1 1 linked to the 17. Now they form the 1 1 1 is 7. Now that's 1 1 1 in binary notation is 7, and linked to a 7, that makes 7 7, and 7 plus 7 is equal to 14. So that explains that. Virtual number is, for instance, let's say you had 27 and a sequence to 36. Well, that virtual number, if it sequences to another 36, that equals 72. And one way 72 is represented, because this is beyond, this is Super Lotto Plus, so it's above, the numbers are way above, because I think the highest number is 48 here. But so anyhow, this 27 represents 72 in virtual memory, in virtual mode, and so that's how you would get a 36 sequence. And then there's metamorphic numbers. Metamorphic number, for instance, would be like this number right here, 11 to 8 linked together. For instance, let me see if I have one here. Here's the 11 8, right? And so what you have, if you were to convert those double zeros on that 8 and put them like this, and then link to the 11, what you form is a 1 linked to a 0. That makes a metamorphic 6. And another one linked to a 0. That makes another metamorphic 6. So what you get is 6, 6. And 6 plus 6 is equal to 12. That's how metamorphic numbers work. And statements and expressions, basically, like for instance, this number right here, 29, it carries a statement. And what is the statement? The statement is 2 9s. What is 2 9s? 9 9. 9 plus 9 is equal to 18. So these numbers have statements. And then there's anatomical numbers. An anatomical number would be, for instance, number 17 that sequences to a 4. Now the reason why the 17 is anatomical is because it has all the elements to make a 4. It has the 1 and the upside down 7. And so that's an anatomical sequence. And then you have bridge numbers. Bridge numbers is the 11, 13, and 14. They help to bridge sequences. Another concept is the count number. Count numbers are basically repeat. Like for instance, let's say you want to know if the 38 is going to be repeated, like right here, see? And so what you would do is you count the distance between here and here, and whatever that distance is, for instance, let me see here. For instance, this number here and this number here, if you were to assume that there's a 38 there, right? The distance between here, this number, and this number is 38. So the actual count number is itself. So the distance between here and here is 38. So this tells you that this number is going to be 38. So we're going to talk just a little bit about how the calendar dates are help to sequence the sequences, and even though these are things that were developed in the past, right? But in the present, they have sequential potential within these sequences that are taking place, and there's a relationship there. So, like for instance, right here, you have 38, right? And so let's assume that you do assume a 38 here. right? And then what you do is basically you look to see where, if there was a previous 38, and the next previous 38 is right here. And as I said, if you count the distance between here and here, if you get, like for instance, if it's 38, the count is like the distance between here and here is 38. That tells you that that number is 38. This 38 is going to be played out. Or if there was a 38 next door, like right here or here, that if there's a neighbor that spells out 38, then that tells you that the 38 is a valid sequence right there. So you're assuming that that this is going to be played out, and so you put your number right there. But what we're going to talk right now is this powerful sequence. It's the 70. Now let me explain the 70. The 70 is equal to 35-35 sequence. Whenever you get a number like a 7 that links to a 0, that makes 70, and that's a very, very powerful sequence. What you're going to get is you're going to get a 35-35 sequence. Now it could be 35 formed like this, see, or it could be two cells that form 35. In other words, like over here, the 13 got played out. So what happens is that, knowing that, because this is the sequences that we're focusing in on, knowing that a 15 got formed, now you know. Let me explain how the 15 develops. 35 is equal to the statement 3 5s, which is 5, 5, 5. And 5 plus 5 plus 5 is equal to 15. So the 15 is equal to 35, and 35 is equal to 15. So now we know that because of the 70, we know that there's going to be a 35 sequence, right? And so the moment we see that 15, we already have a relationship, because we know that 15 is equal to 35. So that means that you're going to put a 35 there, right? And now you know that you got to form another 35. One way that you could form another 35 is by using the number 13. That makes this like a very, very strong expression of 35. And what you have here is the numbers on the right hand side, they form 35. The numbers on the left hand side are statements. In other words, this is the 1, which is the equal statement, in like equals in mathematics, equals what? 35. So the 13 is a very strong number to form another 35. So what you have here is 70. Now this forms 70 right here, right? And even this number to the right links to this number to this 0, so there's a very strong 70. And the moment that 15 shows up, you already have a relationship. You already know that this sequence is taking place. So it's going to create a 35, and then you're going to have to create another 35, and it can't be on the same line, right? So what you have to do is you have to use the 13 to form that 35. And once you do that, then you form a 35, and that's equal to 70. Okay, so I'd like to talk about, now that we have established that the 13 is going to be played out, and the 35 is going to play out, so we have a number over here that we have to determine what the sequence is going to be right there. And one way to find out is that we could figure out what these numbers are going to be. In other words, the 28 carries a statement 2 8s, which is 8, 8. 8 plus 8 is equal to 16. So that is a possibility. This number here is related to 16. 2 8s is 8, 8. 8 plus 8 is equal to 16. The 29 is equal to 18. 2 9s is 9, 9. 9 plus 9 is equal to 18. So there's two numbers that are possible here. They're the 16 or the 18. And so what you do is you go over here and notice how you have 16 here, right? And then you have, so we're saying that it's possible it's going to be 16. So what you do is you count the distance between here and here, and whatever that distance is. In other words, it's I already know it's 56, and so by seeing that you have a 5 there on the right hand side linked to this number right here, that makes 56. And if you go over here, you got a 5 that links to this 6. And this 5 links to this 6, 56, and this 5 links to this 6, and it makes 56. So we already know that the count number between this 16 and this 16 is 56. So we already know that this number is going to be 16. And so now that you have these three numbers, you already know, because a lot of these sequences, like for instance the 1316, whenever you get a 1316, it sequences to a 36. So now you know that this number is going to be a 36. You see? Because knowing that these two numbers exist, that's equal to 36. And so you already know that this answer is going to be 36, and you already got the 35. Now the only thing is that now, for instance, if you were we already determined that the 38 was going to play out over here, because the distance between this 38 and this 38 is 38. So we already know that is going to be played out. Another thing that's very important is that notice how you have the 50 here. See that? The 50? And so we have a 50 right here. So frequency of occurrence means that there's something going to happen that's related to 50. And what is related to 50? 25 plus 25. So we already know that the 25 is the bonus number. So that explains all these sequences right here. So I hope you enjoyed the sequences here, and I'll be dealing with a lot more Super Lotto Plus, and this channel is basically sequencing random numbers. I have another one called The Wonderful World of Random Sequencing, but this is the one where I'll be doing a lot of Lotto, Super Lotto Plus, and probably Fantasy 5. So give me some thumbs up, subscribe, and spread the word. We'll see you on the next Wonderful World of Random Sequencing and sequencing random numbers. That's the other channel.